Hello guys, welcome to NCERT Science. We are reading class 6 chapter number 9 Science, Electricity and Circuit. Let's start. We use electricity for many purposes to make our task easier. For example, we use electricity to operate a pump that lifts water from wells or from ground level to the rooftop tanks. What are other purposes for which you use electricity? List some of them in your notebook. Does your list include the use of electricity for lighting? Electricity make it possible to light our homes, roads, office, markets and factories even after sunset. This helps us to continue working at night. A power station provides us with electricity. However, the supply of electricity may fail or it may not be available at some places. In such situation, a torch is sometimes used for providing light. A torch has a bulb that lights up when it is switched on. Where does the torch get electricity from? Electric cells. Electricity to the bulb in a torch is provided by the electricity cell. Electric cells are also used in alarm clocks, wristwatch, transistor radios, cameras and many other devices. Have you ever carefully looked at an electrical cell? You might have noticed that it has a small metal cap on one side and metal disc on the other side. Did you notice a positive sign and a negative sign marked on the electric cell? The metal cap is the positive terminals of the electric cell and the metal disc is the negative terminal. All electric cells have two terminals, a positive terminal and a negative terminal. And electric cells produce electricity from the chemical stored inside it. When the chemical in the electric cell are used up, the electric cell stops producing electricity. The electric cell then has to be replaced with a new one. A torch bulb has an outer case of glass that is fixed on a metallic base. What is inside the glass case of the bulb? Caution. You might have seen the danger signs shown there displayed on poles, electric substations and many other places. Warn people that electricity can be dangerous if not handled properly. Carelessness is handling electricity and electric device can cause severe injuries and sometimes even death. Hence, you should never attempt to experiment with the electric wires and socket. Also remember that the electricity generated by portable generator is equally dangerous. Use only electric cell for all activities related to electricity. Now activity 1. Take a torch and look inside its bulb. You can also take out the bulb with the help of your teacher. What do you notice? Do you find a thin wire fixed in the middle of the glass bulb? Now switch the torch on and observe which part of the bulb is glowing. The thin wire that gives off light is called filaments of the bulb. The filament is fixed to two thicker wires which also provide support to it, as shown in figure 9.2b. One of these thick wires is connected to the metal case at the base of the bulb. The other thick wire is connected to the metal tip at the center of the base. The base of the bulb and the metal tip of the base are two terminals of the bulb. These two terminals are fixed in such a way that they do not touch each other. The electric bulb used at home also have a similar design. Thus, both the electric cell and the bulb have two terminals each. Why do they have these two terminals? Caution. Never join the two terminals of the electric cells without connecting them through a switch and a device like a bulb. If you do so, the chemical in the electric cells get used up very fast and the cells stop working. A bulb connected to the electric cell. Let us try to make an electric bulb light up using an electric cell. How do we do that? Activity 2. Take 4 lengths of electric wire with differently colored plastic coverings. Remove a little of the plastic covering from each length of the wire and the end. This would expose the metal wires at the end of each length. Fix the exposed part of two wires to the cells and the other two of the bulb as shown in figure 9.3 and figure 9.4. You can stick the wire to the bulb with the tape used by electricians. Use rubber band or tape to fix the wire to the cell. Now connected the wire fixed to the bulb with those attached to the cell in 6 different ways as have been shown in figure 9.5 A to F. For each arrangement, find out whether the bulb glow or not. Write yes or no for each arrangement in your notebook. Now carefully look at the arrangement in which the bulb glow. Compare these with those in which the bulb does not glow. Can you find the reason for the difference? Keep the tip of your pencil on the wire near on one terminal on the electric cell for the arrangement in 9.5. Move the pencil along the wire all the way to the bulb. Now, from the other terminals of the bulb, move along the other wire connected to the cells. Repeat this exercise for all the other arrangement. Did the bulb glow for the arrangement in which you would not move the pencil from one terminal to other? An electric circuit. In activity 2, you connected one terminal of the electric cells to the other terminal through wire passing to and from the electric bulb. Note that in the arrangement shown in figure 9.5a and f, the two terminals of the electric cell wire were connected to two terminals of the bulb. Such arrangement is an example of an electric circuit. The electric circuits provide a complete path for electricity to pass, current to flow between the two terminals of the electric cell. The bulb glow only when current flow through the circuit. In electric circuit, the direction of current is taken to be from the positive to the negative terminals of the electric cell as shown in figure 9.6. When the terminals of the bulbs are connected with that of the electric cells by wire, the current passes through the filament of the bulb. This makes the bulb glow. Sometimes an electric bulb does not glow even if it is connected to the cell. This may happen if the bulb has fused. Look at fused bulb carefully and the filament inside it intact. An electric bulb may fuse due to many reasons. One reason for the bulb to fuse a break in a filament. A break in the filaments of an electric bulb means a break in the path of the current between the terminals of the electric cell. Therefore, a fused bulb does not light up as no current passes through its filament. Can you now explain why the bulb did not glow when you tried to do so with the arrangement shown in figure 9.5 B, C, D and E? Now we know how to make a bulb light up using an electric cell. Would you like to make a torch for yourself? Activity 3. Take a torch bulb and a piece of a wire. Remove the plastic covering at the two ends of the wire as you did before. Wrap one end of wire around the base of an electric bulb as shown in figure 9.7. Fix the other end of wire to the negative terminals of an electric cells with a rubber band. Now bring the tip of the base of the bulb, that is, its other terminal in contact with the positive terminals of cell. Does the bulb glow? Now move the bulb away from the terminal of the electric cell. Does the bulb remain lighted? Is this not similar to what you do when you switch your torch on or off? Paheli has another arrangement of the cell and the bulb. Will the torch bulb glow in the following arrangement? Electric switch. We had an arrangement for switching on or off or homemade torch by moving the base of the bulb away from the tip of the cell. This was a simply switch but not very easy to use. We can make another simple and easier switch to use in our circuit. Activity 4. You can make a switch using 2 drawing pins, a safety pin or a paper clip, 2 wire and a small sheet of thermocol or a wooden board. Insert a drawing pin into the ring at one end of the safety pin and fix it on the thermocol sheet as shown figure 9.8. Make sure that a safety pin can be rotated freely. Now fix the other drawing pin on the thermocol sheet in a way that the free end of the safety pin can touch it. The safety pin fixed in this way would be your switch in this activity. Now make a circuit by connecting an electric cell and the bulb with this switch as shown in figure 9.9. Rotate the safety pin so that its free end touches the other drawing pin. What do you observe? Now move the safety pin away. Does the bulb continue to glow? The safety pin covered the gap between the drawing pin when you made in touch two of them. In this position, the switch is set to be on. Since the material of the safety pin allows the current to pass through it, the circuit was complete, hence the bulb glowed. On the other hand, the bulb did not glow when the safety pin was not in touch with the other drawing pins. The circuit was not complete as there was a gap between two drawing pins. In this position, the switch is set to be off as in figure 9. A switch is the simple device that either break the circuit or complete it. The switch is used in lighting of circuits, electric bulb and other device in homes work on the same principle, although their design are more complex. Electric conductor and insulators. In all our activity, we have used metal wire to make a circuit. Suppose we use a cotton thread instead of a metal wire to make a circuit. Do you think that the bulb will light up in such a circuit? What material can be used in electric circuit so that the current can pass through them? Let us find out. Activity 5. Disconnect the switch from the electric circuit you used for activity 4. This would leave you with two free ends of wire as shown in figure 9.12. A. Bring the free end of the two wires close to let them touch each other. Does the bulb light up? You can now use the arrangement to the test whether any given material allow current to pass through if or not. Collect a sample of different types of materials such as coins, cork, rubber, glass, keys, pins, plastic scales, wooden blocks, aluminum foil, candle, swing, needle, thermocols, paper and pencil leads. One by one, bring the free ends of wire of the testers in contact with two ends of the sample you have collected. Make sure that the two wires do not touch each other while you are doing so. Does the bulb glow in each cases? Make a table in your notebook similar to table 9.1 and record your observation. What do you find? The bulb does not glow when the free ends of a wire are in contact with some of the material you have tested. This means that these materials do not allow the electric current to pass through them. On the other hand, some material allow electric current to pass through them, which is indicated by the glowing bulb. Material which allow electric current to pass through them are conductor of electricity. Insulator do not allow electric current to pass through them. With the help of table 9.1, name the materials that are conductor of electricity and also those electric of insulator. Conductor and insulators. What do you conclude? Which material are conductors of which and which are insulators? Recall the object that we grouped as those having luster in chapter 2. Are they the conductors? It now seems easy to understand why copper, aluminium and other metals are used for making wires. Let us recall activity 4 in which we made electric circuit with a switch. When the switch was in the open position were the two drawing pins not connected with each other through the thermocol sheets. But thermocol you may have found in an insulator. What about the air between the gaps? Since the bulb does not glow when there is only air in the gap between the drawing pins in your switch, it means that air is also an insulator. Conductor and insulator are equally important for us. Switches, electrical plug sockets are made of conductor. On the other hand, rubber and plastics are used for covering electric wire, plug tops, switches, and other part of electrical appliance which people might touch. Caution: your body is a conductor of electricity, therefore be careful when you handle the electric appliance. Electric cells is the source of electricity. An electric cell has two terminals, one is called positive while the other is negative. An electric bulb has a filament that is connected to the terminals. An electric bulb glows when electric current passes through it. In closed circuits, the electric current passes from one terminal to electric cell to the other terminal. Switch is a simple device that is used to either break the electric circuit to complete it. Material that allow electric current to pass through them are called conductor. Material that do not allow electric current to pass through them are called insulator. Thank you.